Hello everyone, good evening, how are you all? So yes, welcome back to Example, and yes, today we are going to start with the physics part, and our first topic will be study of physical quantities. Now what kind of questions are asked from this part? Here we will be having questions from some of the units. It may be asked what is the dimensional formula for some of the units. There may be the question from the derived units. Now these terms which I am actually using, derived terms, fundamental, what are these? Apart from that, what is this dimensional formula? We have understood, sir, okay, the formulas are there in the maths, but in physics, dimensional formula, is it some sort of dimension or what? So we are going to understand each and everything with the theory part, and yes, in the ending, we'll be having question answer session as well. So who all have joined us? I'm waiting for the comments from you all. So I'll just take one more minute for the comments. So yes, now your comments will be visible. Actually, your comments are not visible. So what I was saying, I am starting with the study of physical quantities, which is the important section from the physics part. And yes, let's see who all have joined here. Actually, your comments were not visible. So these will be visible within 15 to 20 seconds, just half a minute more. So okay then, I am starting the chapter till then. Within 15 to 20 seconds, this issue will be resolved. So yes, first of all, let's start. What is this physical quantity exactly? If I talk about this physical quantity, okay, so HR has joined us. Hello HR, how are you? Good evening. Vanakkam HR. So yes, actually I was talking about this physical quantity. So it is anything that can be measured. Anything that can be measured. Now what can be its example? You can talk about anything. For example, we can talk about any kilogram. We can talk about any meter. That is, we can talk about any of the quantity which can be actually measured. So the comparison of a given physical quantity with the known standard quantity of the same nature. Now, what is it? Let's have an example. First of all, I'll talk about the scalar quantity. What is scalar quantity? It is a physical quantity with only magnitude. Let's take an example. If I talk about temperature, we get the value in degree centigrade or degree Fahrenheit or Kelvin. Whatever we are getting, these values are actually fixed where there is no such direction involved, correct? Again I am saying here no such direction is involved. No one is saying you are having 100 degrees. Here we are talking about the vector quantity. Now let's take an example. You can see this image where car is moving. Now car must be moving in some of the direction. Maybe in east, maybe in west, north, south. There must be some direction. True. So whenever we are talking about any of that particular unit in which direction is also involved, that is actually known as vector quantity. So I guess this term is actually clear to everyone. So first of all, I want to ask you all, is this particular point clear? When we are talking about the direction, so all those quantities in which direction is there, that will be vector. When direction is not involved, that would be known as scalar. So if these things are clear, only then I'll be moving forward. So HR and everyone who has joined the section, kindly like this session and share it, because these are the basic things. All these basic things will be very useful in the physics part. So yes, who all have joined, kindly tell your name so that I can start conversation with you all. And yes, please like this session. Okay then. First of all, let's talk about fundamental quantities. Now, what are these fundamental quantities? Fundamental quantities are the ones which are not derived from anyone else. That is, they are not dependent on anyone. Here, I'll talk about 7 fundamental quantities which are actually not dependent on anyone. Can you tell any one of them? I'm writing some of them. If I'll talk about distance. So here, I'll tell you that I am measuring it with the meter. Now we are aware of, we are not dependent on anything else. For example, if I'll write area, so what is the unit for area? If I'm writing meter square, this means I'm using meter twice, true? So this means it is actually derived, but this cannot be broken into some other parts, correct? So this will be what? This will be fundamental quantity and this is going to be derived quantity. So this is the difference. Let's come back again to our point again. The physical quantity which does not derive from other quantities. For example, you can talk about length. We were discussing about meter, correct? Length unit is meter. If I talk about mass, you can talk about kilogram over here. Time, second. So these are known as fundamental units because they are not dependent on any other unit. But if I talk about derived quantities, the units that can be obtained from fundamental quantities. We have taken its example. Got my point? So it's as simple as that. I guess this point is clear to everyone. Everyone, waiting for your comment. Okay then. Now if I talk about those 7 important fundamental quantities, so what are they? First of all, let's talk about weight. Whenever we are talking about weight, so here you can talk about mass, true. Here it is not actually dependent on anyone. Similarly for meter, that is length. Then comes your time, that is second. Then your current, ampere, temperature, Kelvin. Then if I'll talk about the amount of substance, that is mole. Then if I'll talk about the luminous intensity, so here that is having the symbol, that is unit is candela. So these things are not derived from any other thing, correct? That's why I'll say that these are fundamental quantities. Now what is actually the difference between fundamental and derived? Before that, I want to ask, is there anything that you want to ask? Anyone? So HR, others, waiting for the comment. Is there any kind of doubt that you want to ask? Anyone? Then I'll move forward. So I guess these things are clear to you all, huh? So okay, now waiting for you all. Still, is there any doubt so that I can proceed forward then? I guess everything is clear. Okay. Now we were discussing about the difference between this fundamental unit and derived unit. We have already discussed those units which are not dependent on any other one. That is, I can say that they are directly independent. So just have a look. Fundamental units are those units which are independent of any other unit, including themselves. So they are not dependent on anyone. But in case of derived units, the case is going to be reverse. That is, these derived units are dependent. So derived units are those units which are obtained by multiplying or dividing one or more fundamental units with or without introducing any other numerical factor. So this is actually opposite of fundamental quantity. Fundamental units cannot be further reduced to elementary level. In fact, these are elementary units, but derived units can be reduced to its elementary level, which are composed of fundamental units. We have discussed about it. When I was talking about this fundamental unit, I was talking, for example, let's talk about the length. We're talking about meter, correct? But if I talk about the area, it will be what? It will be meter square. That is, I can say that it is what? It is meter cross meter. Got my point? So yes, this is the derived quantity. Now, fundamental units cannot be expressed in the terms of derived units, but derived units can be expressed in the terms of fundamental units. It's a basic concept, but yes, it is there. Then, only 7 fundamental units exist in the metric system or SI system. How many? 7. Now, this question is asked in the examination. It's the basic one, but it is asked, how many fundamental units are there? So, please remember, those are 7. Now, can you name any one of them? Let's see who is listening this lecture in the proper manner, because this is asked in the examination. There will be 4 units in which one of them would be the fundamental and others would be derived, or one of them will be derived, other would be fundamental, and question can be twisted in any way. So my question is, can you name any one of the fundamental unit? Anyone? Let's see who can answer this, because in the next part I'll be explaining you what are exactly those units. So just waiting for the answer. Is there anyone who can tell this? Okay, so see, when I'm talking about the 7 fundamental units, what are they? Here you can talk about meter, then you can talk about kilogram, you can talk about second, then Kelvin for the temperature, mole, then ampere, candela, all these are what? These are fundamental quantities. Fine, fundamental units. So here we have a 7 fundamental units, yeah, these are mentioned: meter, kilogram, second, Kelvin, mole, ampere, and candela. But if I talk about derived units, these actually exist a large number of derived units in the metric system, and few of them are Newton, Joule, Watt, Volt, Pascal, Celsius, dependent. Now I have a point here. If I'm talking about Newton, can you tell me apart from Newton what I can, how can I actually write it? HR is saying something, sir, meter, kilogram, etc. That's true, that's true. So I guess I'm getting comments quite late. That's the correct one, HR. So if I talk about Newton over here, I can also mention it as kg meter per second square. Okay, one more thing is there, I'll tell you. It's asked in the examination, it was asked actually. If I'm talking about Newton, this means I'm talking about force, correct? So this is actually the SI unit. I'll take another color. I'll take blue color to explain this. This Newton is actually the SI unit. But if someone asks me about the CGS unit, so can you tell me what will be the CGS unit of this force? Anyone? I'm asking about the CGS unit. So I have a trick here. I'll just take its real world example. HR, let's have a discussion. If I talk about anyone's wife or girlfriend, what happens? They always keep on sucking blood of their boyfriends and husbands. True? In one way or the another. So what happened when Newton was actually doing all those discoveries? Newton gave his name as the unit. Correct? So what happened? His wife or girlfriend, let's say anything, she was like this. What is this, Newton? You always keep your name in the units and all. So Newton did what? Newton told, okay, Diane, I'll give your unit also. Okay, Diane, I'll give unit in your name as well. So it's actually not the real one. I've actually told you for an example. So here you can just put what? This is the CGS unit and that is Diane. So he has given his name for the SI unit, that is Newton, but CGS unit is what? Diane. This is asked in the examination, so we must be aware of it. Okay then. So here these are actually the derived units which are dependent on this part, fundamental part. So let's have a discussion on the fundamental unit. First of all comes your meter. Now there's a standard definition for everything. It's not like that someone is coming and saying, okay, from today I'll be starting my own unit. So there's a unit which whole world has accepted. See, there's a difference. I can take the example in the UP part, in this North India part. We have several units for measuring this length. There will be ek angul, fine, ek haath ki distance. So there are several. Sorry sir, please again one time, last Newton. HR, I was actually just telling you. No doubt. If I talk about the Newton, that is the unit of force, correct? The unit of force is what? That is Newton. But if I'll write kg meter per second square, that is also true. That's correct. But Newton is what? Newton is actually the SI unit. But if someone will ask you, what is the CGS unit? So you must be knowing that also, because it is asked in the examination, what is the CGS unit? So actually I was just creating a story so that you can easily understand that. So I was saying that once Newton was actually doing the discoveries and all, so what he did, he gave his name for the units. Now this part is totally correct, but next one is hypothetical. I have just created that story in order to make you understand or remember this fact, that his girlfriend or wife was actually saying that you always keep on giving your name as the unit. Why you're not giving my name? So he did what? He told, okay Diane, I am giving your name. I guess you are aware of that word, not Diane. That is Hindi term for the female vampire or monster, rather I'll say monster. So yeah, so he said, okay Diane, I'll give you a name. So from that word, I was actually telling you how to remember that, how to mug that up. Okay then, I'm coming on the next point. So I was actually talking about meter. Normally what happens, if you will go to different places, you will be having different units of length, correct? But there must be some unit which must be worldwide accepted, so that whatever I am selling for the business purpose, if I am selling something, so if someone is from China or if someone is from Mongolia, from wherever that person belongs, he must understand what I am actually talking about. So there are units which are worldwide accepted, that are the standard units, fine. So those are actually internationally accepted. We call them SI units. Where if I talk about meter, the currently accepted definition of meter is the length of path travelled by the light in vacuum in 1/2 299,792,458 second. So this is exactly the value of meter. Fine. And yes, everyone who has joined, kindly like this session. Next, move forward now. If I talk about kilogram, so again the same thing. There are several units. Whenever we go for buying vegetable, we say that I want 500 grams this particular vegetable. I want half kg vegetable. So different units which we use, correct? If you will go to the British region, they use the concept of pounds. Pounds, this much pound, that much pound. So yes, these all are the units of what? Weight. But if I'll talk about the standard definition of kilogram, what is it? Kilogram is the fundamental unit of mass. It is defined as the mass of a specific cylinder of platinum iridium kept at the International Bureau of Weight and Measures in Paris. So in Paris, it is kept. Now its weight is exactly 1 kilogram, and from here comes the definition. So this is actually the reference. Using this reference, we are all having those particular weights. Fine. So from where this 1 kilogram is coming, we have actually kept it as a standard, and using the standard, we are having all those replicas. Fine. Or we'll say that is exactly telling us that, okay, this is the 1 kg, this is half kg, this is 250 grams and all. Fine. So this is the definition of kilogram. Again, I'll say it is defined as the mass of a specific cylinder of platinum iridium kept at the International Bureau of Weights and Measures in Paris. So it is actually placed in Paris. So I guess now definition is clear with everyone. Is there anyone who is having any doubt here? From where these definitions are coming? What are these exactly? I guess I'm able to explain all these things. Whatever you are not getting, please let me know. So this is the thing. Here comes the definition of kilogram. Next. Now, what is the definition for second? Again, there must be some sort of reference. True. So yes, here second is the fundamental unit of time. It is defined as 86,400th part of a mean solar day. Second is accurately measured by an atomic clock. So this is the atomic clock. So just have a look. From here, you can understand what is second. So second is again a fundamental unit of time, which is defined as 86,400th part of a mean solar day. So here we come with the exact definition of a second. Now, we were talking about those particular quantities. Now there must be some units. So first of all, if I'll talk about mass, so we have symbol m, and here we have kilogram as the unit. In the similar way, for the length, we have meter as the unit. For time, we have second. Okay, so here's a question, very important one. I'll take red pen over here. I'll mark as important as well. What happens? In the examination, when we come across the mass, we know that it is kilogram. Now I'll tell you where actually doubt comes and where we go wrong. So it is from the past experiences I'm telling you. When someone is asking you about the mass, you'll directly say that it is kilogram. But when someone asks you about the time, what is the SI unit of time? Now this was asked actually in the examination. That's why I'm saying there are options which are given. One option is hour, second option is minute, third option is second, and fourth option is nanosecond. For example, so I'll ask you, what is the SI unit of this time? Can you tell me? What is the SI unit of time? Is it hour, minute, second, or nanosecond? Can you tell me this? Now this is the location where we go wrong. So yes, waiting for the answer from everyone. Can you tell me about it? Waiting for the answer. What is going to be the correct answer? Is it hour? Is it minute? Is it second? Or is it nanosecond? Who can give me this answer? Everyone waiting for the answer. No one? So please remember, when we are talking about this time, here second is going to be the correct answer. Please do not go with those those R's and all. Totally correct, HR. Harish, totally correct. Great. If I talk about current, here comes ampere, temperature Kelvin, amount of substance is the mole, and luminous intensity is candela. Next, what about coulomb? What is coulomb? The fundamental unit of charge. It is actually the fundamental unit of charge. It is defined as the charge required to obtain 9 into 10 to the power 9 Newton force between two equal charges which are separated at a distance of 1 meter in vacuum. Fine. So this is actually coulomb. So coulomb is what? It is the unit of charge. Next, talking about candela. The fundamental unit of luminous intensity. It is defined as the luminous intensity obtained from a source of monochromatic light of frequency 540 cross 10 to the power 12 hertz. That is an intensity of 1 by 683 watt per steradian. Now, here comes the doubt of, sir, what is the steradian? So, do you know, when we will talk about angle, so there we have a unit that is radian. Now, we have two units there, radian and steradian. So, if I'll talk about those 3D structures, if we talk about civil engineering, civil engineers have a look at the structure of the 3D walls and all, where we must be having some angles, correct? So, there we use this concept. So, please remember, when we are talking about the 3D diagrams, there we have the angles where we use these units. Fine. So, that is steradian. So, I guess these things are clear to you now. Next, talking about Kelvin. So, Kelvin is what? It is the unit which is helping us in getting the exact unit of temperature. For example, I am feeling cold. So, this is the degree centigrade that is present over here. I have been in the fever. I was having 101 degree Fahrenheit. In the similar way, if I talk about the SI unit, you must talk about Kelvin. So, there's a formula actually for the conversion. If I talk about the conversion from degree centigrade to Kelvin, so there's a formula. What is it? C plus 273 gives you Kelvin's value. So, this is the formula. Please remember, I'll be having one of the question also today. So, actually its exact value is 273.15. Fine. So, I'll directly write 273 because in most of the cases only this one would be asked. So, this is the thing we must be aware of. Okay then. Now, we will be having some of the questions. Before that, let me tell you about mole. The fundamental unit of quantity of a matter. It is defined as the amount of substance of a system that contains as many elementary particles as there are in the 0.012 kilogram of carbon 12. So, this is about mole. Now, what are derived dimensions? We were aware of. They are actually dependent on other quantities, where we were talking about fundamental quantities. In the similar manner, if I talk about derived dimensions, so the units that can be obtained from fundamental units are under this derived dimensions. So, if I talk about some of the derived units, you can talk about any of the unit, whatever is coming to your mind, apart from those 7 fundamental units. Here, what are they? First of all, area. Just have a look. Square meter, that is derived. I was talking about what? Meter cross meter. So, it is derived. Yes. Then, if I talk about volume, that is what? L cube. Now, this is meter cube. So, meter cross meter, derived. But one thing is there. Let's have a look about this dimension which we are talking about. Do you know how to take out these dimensions? If you're not aware, I'll let you know, but I want the answer from everyone so that I can explain this part. This is asked in the examination. Are you aware how this L cube is coming? How this L by T is there for the velocity? For the work, it is ml squared T power 2. How it actually comes? So, if anyone is having doubt regarding same, please let me know so that I can explain this part. If there is no doubt, I'll be having questions within next 5 to 10 minutes. But want answer from everyone. Is there any doubt regarding this? Are you all aware of what is dimension? I'll be waiting for you all in the comment section. I want. So, yes, if I talk about velocity, so we have meter per second. Again, length, meter, time, second. So, this means it is again derived, correct? But since we are talking about the dimension, its dimension is L by T. Then, talking about angular velocity, symbol is omega. Dimension is 1 by T and it is 1 upon second square. Second square, no, it would be 1 by second. Fine. So, yes, these things are derived dimensions where we have other dimensions as well. You can talk about acceleration, that is L by T square. Then angular velocity 1 by T, acceleration L by T square, angular acceleration 1 by T square, force ml T minus 2. These are the dimensions. Now, if anyone has doubt, please let me know. Okay, so you are aware of these things now. Okay, then no issues. So, let's see. I'll have one of the question. Let's discuss about acceleration. So, can you tell me what is going to be its dimension? HR. Since you are live here, so I'll be waiting for the answer. Are you aware of what is the dimension of this acceleration? HR, waiting for your answer, then I'll move forward. Because after this, we are going to have question answer session within 2 to 3 minutes. So, just want the rough idea whether you are aware of this or not. From the question, then we'll get to know. because in the questions we are going to have the discussion on the significant figures also. Questions are asked from the significant figures and we are in the state of doubt that what are they, how are actually they calculated. So before that I want this answer. What is the unit for this acceleration? Sorry. What is the dimension for this acceleration? Now if I talk about the unit, we know that it is what? Meter per second square. True? But now meter per second square. Totally correct HR. So if I'll talk about the dimensions, we write M, L, T. We use this where M denotes mass, L denotes length and T denotes time. Simple. Now if I talk about mass, this means here whenever we'll check the unit, just have a look. Is there kg there? Yeah, anything is there that is related to this particular mass? If anything is here, we'll do what? We'll put power according to that. For example, if I'm talking about meter, this means I'm talking about length. Then upon second square, second is what? Time. So it is times square. So it will be t square. So this would be the dimension. So what is the dimension of this? It will be either I can write LT minus 2 or I can write L by t square or I can write M0 L t minus 2. So in this manner I can write about its dimension. So now let's have a question. Before that, let me tell you, if I talk about the derived dimensions, so we are using length, that is meter. For the volume we have meter cross meter cross meter. Similarly for mass we have kilogram. So density we write kg per meter cube. So all these are the derived dimensions. So conversion of units, the basic conversion of mass, length and time from SI to CGS are as follows. 1 kg is equal to 1000 grams. 1 meter is 100 centimeter, sorry. 1 meter is 100 centimeter. And similarly, obviously 1 second will be 1 second. So first of all, I will be having first basic question. Fine. So yes, we are going to start with the question answer session now. First of all, let me tell you there's an exam for application, which is one-stop solution for the government job aspirants. We have live paid courses with the test series, free subject-wise and topic-wise quizzes with the report card, job alerts, admit card, examination date, whatnot. Daily current affair, weekly current affair, we have all those things. Just go to the Play Store, type Examper, click on the install button, go to the open part and just register it and start using it. So the first question comes here on the screen and it is the basic one. From next question onwards, we will be having significant figures question answer. So first is the basic one. Let's see who answers this in the super fast manner. You have to convert 2 kilometer into the centimeter. Just convert it. 2 kilometer into centimeter. I'll write here. All these are centimeters. Just want answer in the super fast manner. 1, 2, 3, 4. Which one? Very basic question. Too basic. Extremely basic. Just to give you idea. Yes. So it's very obvious. If I'm talking about kilometers, so 1 kilometer is equal to 1000 meter and 1 meter is equal to 100 centimeter. So if I want to convert 1 kilometer to centimeter, what I have to do? I'll use this. That is 5 zeros must be there. So it's very obvious. What? Option number A, that is 2 into 10 to the power 5 would be the correct answer. Next, here comes the question where doubt is there. So I want answer from everyone right from this question. What is 0.0683 to two significant figures? What is going to be the correct answer here? Want answer from everyone. Waiting for the answer. What is 0.0683 to two significant figures? What is going to be the correct answer? Just think and then answer. HR is saying something. Actually, your comment is quite. HR is saying, sir, A. Achha, you were talking about last question, HR. Yes, that was totally correct. Awesome. But HR, this answer. Is it 0.6? Is it 0.68? Is it 0.068? Or is it 0.69? What is going to be the correct answer? You have to round off till. Okay, so you are in the doubt, sir. You think it would be C. Okay. So HR, actually your guess is correct over here. Great. Your guess is totally correct. Now I have a point here. You are correct. See, when we are talking about two significant figures, that means 0.0683. I'll use blue pen to explain this. Two significant figures. When we are moving with the significant figure, remember, we are just not counting the zero part. This means first, second. That means I have to go till 0.068. Hello, happy, good evening, how are you? So yes, what I was saying that when you are going to this part, just think that 0 is not there. Fine. Just as if 0 is not existing, so you'll go till 68. But have a look, just after this 8, what we are having. If this value is lesser than 5, leave as it is. Don't worry about that. But if it is 5 or greater than 5, then the value will do what? Here you have to do plus 1. Only this is the difference, nothing else. Fine. So, but here it is what? Here we are just having the value 3, that is, this means we are having the value lesser than 5. So, it will be 0.068. So, you are absolutely correct, HR. That is, option C is the correct one. So, HR, got my point? So, now let's have a look. What is 0.13645 to 3 significant figures? I guess this time you can go with the correct one. So, yes, now these things are important. Do not forget, when I'm talking about these significant figures, there must be no issue in your mind. Whatever doubt is there, just let me know right now. I want you all to be correct. Yes. HR is with V. Sir, it will be 0.136. Totally correct. Awesome. When we are talking about this 3, so this means 0.13645. Let me change the color of the pen. 3, 0. We are not counting. 136, So here, when I am till here, I'll just check. Is it 5 or lesser than 5? Obviously less than 5. So it is going to be 0.136 and your option is HR B. Totally correct. Option number B will be correct. But HR, what if I say the question is 0.13665 and you have to round off to 3 significant figures. The question is same, just the value is changed. Now what is going to be the answer? Let's see. 0.13665. What will be the answer in this case? And it's very important. Please, any sort of doubt if it is there, please let me know. Please let me know if any doubt is there. What is 0.13645 to 3 significant figures? Important one. If you can give correct answer for this, you will be correct for any kind of significant figure. Yes. Waiting for the answer. I guess it is clear. If it is clear, I want the answer. You have given 0.136. HR, this time, I'm sorry to say, but I need to explain this again. See what I told you. When I am going with the 3 figures, 0 I am not including. Nilesh has given the answer 0.137. Totally correct, Nilesh. Awesome. Great. And HR, it's good that you have given the wrong answer. I'm sure next time you will be correct over here. What I told you, just have a look. 3, but before giving any of the answer, I'll just check the next one. Is it 5 or greater than 5? It is more than 5. This means what I'll do? I'll do plus 1 over here and hence my answer will come 0.137. HR, I guess this is correct. And Nilesh, awesome. You are totally correct. So please do not give wrong answer in the mains examination. So I guess this point is clear to you all. Next. What is 77.61 to 3 significant figures? I guess this time answer will be correct. Okay, let's see what is going to be the answer. What is 77.61 to 3 significant figures? What is the correct answer? HR, Nilesh. And give the answer in the super fast manner. What is 77.61 to 3 significant figures? And I'll be asking this same question in twisting 2 more ways. But first this answer. And everyone who has joined, kindly like this session and share it. Yes. What is 77.61 to 3 significant figures? HR is with A. That is 77.6. Nilesh, what is your answer? Nilesh. I guess you are also with the same. Okay. So this was the simple one. Where if I'll say that, sir, it is 77.61 and I am asking about 3 significant figures. Obviously 0 is not there. So I'll be including this part as well. So this is included, this is included, this is included. 3 days are done. Now I'll just check. What about this? It is less than 5. So there is no change needed. And hence 77.6 will be the correct answer. Awesome, HR. And Nilesh is also with 77.6. Totally correct, Nilesh. What if now I am changing my question? Now my question is 77.61, or I'll change this value as 77.66. Now the question is same. What is going to be the answer? What is 77.61, sorry, 77.66 to 3 significant figures? So I guess this time you can give the correct answer. I'll twist this question in one more manner now, one more way. But before that, I want this answer. This is the question. This is the actual value, and you have to convert to 3 significant figures. 3. And we are aware of there is no such 0. Totally correct, Nilesh. Awesome. Absolutely correct. When I'll convert it, I'll just check. 1, 2, 3. I'll go till here, but I'll just check about it. Is it 5 or greater than 5? It's there. Totally correct, HR. Awesome. So this means I'll do what? I'll convert it plus 1, that is, it will be 77.7. Correct? So yes, this time you are correct. So here we have Sai Teja. Sai Teja, you are giving answer for this or this one. So I guess this is clear with everyone. If someone is having doubt, please let me know. Okay then. Now there's another question. What is 1845 to 2 significant figures? Now it may create confusion. Let's see who gives this answer. And everyone who has joined the session, kindly give the like, but do not give like twice. Fine. Just once like is enough. In a similar manner, if I'll talk about the girlfriends, the first girlfriend is enough. No need to go with the second one. That one. So okay, cool, Sai. Sai Teja, I want the answer for this one. What is 1845 to 2 significant figures? If there is any sort of doubt, please let me know. Yes. So Sai Teja is with 1850. So one of the answer is 1850. Then others. Nilesh is with 1800. Okay. So one is 1850, one is with 1800. HR, you are left. So Tamil Nadu police is left to give the answer. Yes, yes. HR is also with 1800. So there are 2 people who are with 1800. One is with 1850. So Sai Teja, do you want to change your answer? No issues. Let's understand how we are working on this part. If I'll write 1845, what I told you when I'll move forward, I'll just check. How many significant figures? 2. So these are the 2 significant figures. True. Now it doesn't matter what is there on the next side, but there's one more condition. Sana is with us and Sana is saying that it will be 1800. Yes, Sana, absolutely correct. So you all have given the answer. Just have a look. These are the 2 dates. These are confirmed. It will be same. Just have a look at the next one. Is it 5 or greater than 5? No. This means there will be no change. So we'll write here what? 1800. Since they are talking about only 2 digits, so this will be the 1. But now my question has changed. Now my question will be, you have to give the value for the 1845. Now you have to go with the 3 significant figures. What is 1845 to 3 significant figures? Let's see who gives this answer. What is 1845 to 3 significant figures? Whoever is having doubt, please let me know. But I want you all to be correct in the main examination, please. And as everyone who has joined the session, kindly like this session and share it. Waiting for the answer. What is 1845 to 3 significant digits? To 3 significant figures. If you will give this answer correct, then everything is going to be correct. 1845 to 3 significant figures. HR is with 1840. Sir, it will be 1840. Okay. So we have one of the answer is 1840. Others. Then we have Sai Teja also with 1840. That is, we are having 2 of the options here. Then Sana and Nilesh. You are also with the same answer. Just use those particular steps. Don't miss any of these steps. Sana, Nilesh. No issues. If you will go wrong, I'll explain now. Why you are worrying about that? Kindly give the answer. Waiting for the answer from both. Nilesh is there, Sana is there. See, if there is any sort of doubt, please let me know, but please don't go wrong. I'm again explaining you. We are talking about three significant figures. This means, I'll take blue color pen. This means I'll go till three places and I'll stop right here because it asked about three significant figures. Simple. Now, just have a look. What I told you, just next one must be checked whether it is 5 or greater than 5. Yes, it is greater than 5. That means we will have plus 1 here. True? This means what is going to happen? This means it will be 1850. Got my point? So, in this condition, 1850 will be the correct answer. HR, Sai Teja, is it okay? Please do not go wrong with this part. I guess you are having doubt. If there is doubt, I'll explain you with another example. But till now, is there any sort of doubt? Any doubt left? Sai Teja, HR, Sana, Nilesh. I was talking about 1845 till three significant figures. That means I'll move till 3. I'll write as it is. But just next one I'll check. Is it 5 or greater than 5? Yes. So that's why I've done plus 1 here. And in this manner, we actually calculated. So please let me know. Is it clear? Yes or no? Please. In this super fast manner. If your comment will get delayed, I'll understand that it is clear to everyone. So in this manner, you will calculate this. Fine. So I'll move forward now. Here 1800 was the correct answer. Next, you have to convert 100 degrees centigrade to Kelvin, and this is a simple one. We discussed a formula. Remember what was it? When we are talking about the conversion, so degree centigrade can be converted into Kelvin by just adding 273, and I'll tell you the exact value. It is actually 273.15. Okay, Sai. I'm getting comments quite late, that's why. Okay, cool. So I was talking about the conversion. This is the formula for the conversion. Now what is degree centigrade? Here the value is given 100. This means if I write 273 here, it will give me what? It will give me 373. But since you must know the exact value, so whenever we convert, we write 273.15 as the value. So yes, Nilesh, you were correct. Totally correct. If I talk about the exact value, when we add it, it is 273.15, which we are talking about. But yes, since the option is here, so according to the options we'll go, and it would be 373K. So Nilesh, you are absolutely correct. Next, which among the following is the fundamental unit? So these are the 4 options. I want answer from everyone. Yes, Sai, Teja, Nilesh, HR, Sana. Who can give me the answer in the first attempt? Which among the following is the fundamental unit? Is it meter cube? Is it meter per second square? Is it meter square, or is it second? What is it? So Sai Teja is with the first one, that is a meter cube. Others? Just think about it. Nilesh, are you also with the same option? Are you with the meter cube? Just have a look at the options. Sai, what I told you when we are talking about fundamental units, these fundamental units are not derived from anyone. They are not dependent on anyone. Now, if I'll go with the option A, that is, we are talking about volume over here, correct? If I'll talk about meter cube, this means I'm talking about meter, cross meter, cross meter. This means, see, I am actually dependent on this meter, correct? So this meter cube is derived from meter. Yes, that's absolutely correct, Sai. Awesome. If I talk about meter per second square, so it is dependent on it. Meter again dependent, but second is the one which is not dependent on anyone. And when any of the unit which is not dependent on anyone, that is known as fundamental unit. That's why option number D is correct. Awesome, Sai. Totally correct. So here option number D is the correct answer. Next, the SI unit of surface acceleration is what? What is the SI unit of surface acceleration? Let's see who gives this answer. Surface acceleration. No sir, I am chosen option D. With, of what? Acha, okay. So I guess I got your comment quite late over there. No issues, no issues. So I'm talking about the SI unit of surface acceleration here. What would be the answer? Will it be meter per second square, Newton, Newton per meter, or Newton meter? What is going to be the correct one? Surface acceleration. I guess I'm getting your comments quite late. So I'll do one thing, I'll directly tell you. If I'm talking about the unit of surface acceleration, it is what? It is meter per second square. You can directly relate it with the acceleration part, correct? So yes, meter per second square is the correct one. Now if I'll talk about the dimensional formula, how you'll derive it, we have explained this part. When we're talking about the dimensional formula, we have MLT, where we just check what is the power. So meter per second square means what? It will be meter. Seconds power will be -2. Now meter is what? Meter is actually length. Length power is 1. So it will be 1. Second, that is time, -2. But m is not there. So m0 L1 t -2. Or I can write LT -2. One and the same thing. So this is the dimensional formula for surface acceleration. So yes, Sai Teja, absolutely correct. So there's a next question with the same part. CGS unit of force is what? So we had the discussion here with the HR, correct? What I was saying that if I talk about force, then the SI unit of force is what? The SI unit of force is actually Newton. But if I talk about the CGS unit, then the CGS unit of the force is dyne. So here option number A will be correct. So that is dyne is the correct answer. Option number A. Next, find the dimensional unit of force. What is the dimensional unit of force? Who can tell me about this? When I talk about the force, this means I am talking about kg meter per second square. Now, I can write it in one more manner. What? Kg meter per second square. Now, kg means what? I am talking about mass. So, I am having m's power 1. Then, meter is what? Length 1. Second means what? Time. That is -2. So, it will be what? It will be mlt -2. Or I can also write in this manner, ml by t square, correct? So yes, here we will be having ml by t square. That is option number A as a correct answer. So yes, here we have ml by t square as the correct answer. So all these were from your physical quantities part, and tomorrow we'll be starting with the force chapter. So please be there in the class at the right time, so that we can cover with lots of examples. And yes, please start conversation so that we can easily conversate with each other and get the clarity. So we have Mahima Mishra here, and she has given correct answer A. Absolutely correct. But you were quite late. So we'll do what? Tomorrow we'll be starting with the fourth chapter, in which if your conversation will be there, I'll be able to give other examples. I have many examples, many tricks, but you need to conversate and ask all those particular doubts. Okay then, so we have example official application with us, where we have all those things, what, like job alerts and all. You can do what? You can go to this Play Store, type example, click on the install button, click on the open part, register it and start using it. So please like this session, share it. In the morning tomorrow, or rather I'll say afternoon, from 12 to 1, we are going to have previous year questions of force, very important, with all the SSC examinations of CPU, CHSL and others. And in the evening, we'll be having theoretical section with theory plus MCQ. Okay then, bye-bye everyone. Please take care.